Hi everybody. So today we learn about the week's egg. We learn about the SQL DML updates. So this is the content of the slide. There are four things. We learn about how to do commits and rollbacks, how to insert the new tuples, how to insert the letter row, and how to do auto increment. Okay, basically the concept of the commit and rollbacks is core things in the relational database world. So all applications we use this day come with an undo button, but this is quite different. With database, every change you make is temporary until you issue a comment. This is because unlike your desktop file, any change you make to the database is actually visible to other database users once they have been permanent. The changes to the data change to the state of the database. For this reason, database system give you the option of making changes on a tentative basis and then deciding whether they should actually be made permanent and visible to everyone else. Until you issue a commit or rollback, all your changes are in limbo, so to speak. Commits mean the changes are made permanent. They are the new state of the database. Everyone can see them. Rollbacks mean the changes are discarded. They never actually existed. Nobody should ever have seen them. Most databases immediately commit every change you make unless you tell them otherwise. Basically, this happens whether you are working from an SQL client like SQL Workbench or using SQL that is embedded in a program. This actually happens with select statement as well, except you don't notice the difference because query makes no changes to the database. Whenever you make any changes, be sure to switch off auto commit first. If you don't do this, there is no undo button. If you make a mistake, correcting can be time consuming and even impossible. Think about working on a production database. If you make a mistake, then this mistake is immediately committed. Other users will make the changes based on the changes before you have time to correct this mistake. So, do not work in auto commit mode unless you are only running queries. Switching auto commit mode off is tantamount in using transaction. Transactions are an important but slightly complex concept we are going to look into the next model. The .NET framework, for example, make you use transaction to get out from of auto commit mode. This is why the syntax is slightly more complicated than Java or the SQL console. Whenever you need to add a new record to a database, you issue an insert to a table. Insert doesn't span several tables. If you want to insert into several tables, we have to issue several insert. The value are put into column name in the listing shown in purple. So the order of the attributes name and the attribute value has to be the same. Listing the attribute that we want to insert value for is entirely optional. But if you don't state the attribute names, the database system will put the value into columns in the order column appear in the table. This depending on you create table statement. If you get the value mixed up and if the data types happen to match, the value will go in the wrong columns. You should therefore always list the attribute name in your insert statement. Make sure the values are listed in the exact same order. Okay, why we run on single insert? You may wonder why we still have to switch off auto commit. If you're working in SQL client, you can run a query that show you the table after the insert. You may notice a problem then, so you can still decide whether to roll back when you have seen the effect of your insert. If you are not working in auto commit mode, you have to issue a correction, which is messy. When you need to insert the new value into several tables, auto commit really is a problem. Because then a single entry in a table may be missing matching entries in another table. Inserting into several tables and then issuing the commit is much better. When you need to make a change to your database that affect many tables, having autocommit switch off is particularly important. So here you make all the addition to all the related tables and then commit everything at once. This ensures that no one can see an order that has no item in it. Speaking of order with the items, so do you think it matters which tuple it is inserted with first? Hopefully it does, because if it doesn't, it means haven't implemented the foreign key relationship properly. First, let's think about which one is the parent and which is the child table. Both tables have the order ID column, but in which table is in the primary key. The fact the same order ID have duplicate in order item table is a dead giveaway. Primary key cannot have duplicate, so ID is order in the primary key, and order ID is order item is the foreign key. But what we could be primary key in the order item. I'm sure you can figure out based on what you already know. If you have implemented a proper foreign key relationship, the parent table entry has to be made first so that there is an entry in the primary table column that the foreign key can reference. If there is a proper foreign key constraint in the child table, not a not null condition in the foreign key column, it is not possible to make the insert into the child table before the entry into the parent table. Another consideration here is that the record for the order table does not include a value for the ship date. If you have declared the ship date as not null, this insert statement will fail. With the order table, we are assuming that we may not know the shipping date at the time we make the order. So the ship date has to allow nulls. Every insert statement has to have value for all fields that are not nullable, or the statement will fail. If you have committed, the table looks like this. Note the primary key are now underlined. Okay, how about into increment? All full-fledged database products let you declare a column as an auto increment column. So this means the database system pick the value itself and ensure it's a consecutive number that is not duplicate. This is a common way of making unique primary key. Okay, basically, you know, uh, in a general way, based on my experience when I design the database, usually primary key I will put as a auto increment. The reason is I want to make sure every table that insert in the data have their own unique primary key. That's the reason. Because when we try to implement data, we will work in a huge of data. Of course, sometimes we are you suddenly 101 112 we see like the same value. But however, for the computer 111 112 is a different things. So the auto increment can be used in order to set the primary key as a generate itself. But however, there's a case that I will not apply the auto increment part. For example, if I want to build a student table that content of the student table, of course the student ID I will not use as a increment key, because Maybe student ID, I will generate it based on the year that they enter and then the semester that they come in. So the auto increment function may not be useful in this part. So I mean the auto increment is like we can use in the others table, like a simple table lah, simple table. For example, you want to generate like a product ID. Maybe you can use it. Actually, it really depends on the database developer itself. Uh, how to design the table more efficient and more proper. Okay, update. Update basically a statement that used to making changes existing database entries. For example, if you want to make a new entry, so we can use update. So by given, if you see this example of the update, update order ship dates 2016-01 to 6 where order ID 113. So that's mean update will update the data by given condition where ID 113. So the coding will search, the computer will search the order ID 13, the primary key. And then it will replace, will update the data attribute of the order date. I mean the attribute of the ship date from null to become 2016-01 to 6. So this is the purpose of the update. With update statement, the most common mistake is to forget the restriction. This means every ship date is the table will have this new date. This is really bad if you haven't disabled auto commit. How are you correct this mistake? How do you find out all the actual ship date? You have to resort to a backup which wouldn't have all the row inserted since the last backup a nightmare. This is such a common problem. MySQL actually asks you for confirmation if you forget the where clause with an update statement. This unusual database expects you to understand what you are doing. Okay, ultimately, you all insert and updates will probably go into same application code. But before you add them into the application, it's good to practice to try them out from an SQL client. Ideally, you will set up a test environment rather than trying your commands on the production database. Nonetheless, even you are working on test database, you want to observe carefully what you change to the database. If you treat the test database carelessly, it will change so much it becomes very different from the production database, and you cannot rely tell them the test database what your SQL statement will do to the real database. Working from an SQL client, before you commit an update, read and what database tell you about the result of your command. If you think too many rows have been matches, you can use select statement to view the result before you commit. Put the same restriction you had in the update statement into the select statement to view what your updates look like. Delete erase tuple from a table. If there is no restriction, no where clauses, every tuple goes and the table is empty. However, do you think this will happen in this case? Order is the parent table of for order items. So if the foreign key constraint in order time has been implemented, the delete will fail for those rows that have child rows in the order item tables. Again, delete is not be used in auto commit mode. The outcome of delete should be checked carefully before they are committed. Basically, delete is a command that used sparingly in practice. In many cases, rather than deleting rows, they are not needed. Production database are often implement a column called deleted whose time is a standard. As long as Deleted column is either null or set to date far in the future. The row is current. Once is set a delete is passed, the row considered deleted. So that's mean usually in real life, we as a programmer, if we want to do like a delete, basically we are not delete. Basically we just transfer the data that we don't want in the table into another table. Okay, the reason is usually user have like a have like a behavior that we call as a careless. Usually user have their own behavior we call as a careless. And when the user become careless, they simply click delete. And then if you really put delete command in the SQL daemon, what will happen is it will delete the data from the table and it will lose from the database forever. This we don't want it. We really don't want it. What actually we do like some kind of like trick lah, like a trick in the user in front of user. They will see like delete command, but however, indeed, in the SQL query, we don't use a delete. We use a command that we can transfer the data that user don't want it to another tables. And then in the in the period of time, maybe the data will delete it. For example, maybe in 1 year you will delete it. It's something which in the real life when the people storing the data, for example in the government lah, I don't know where are you from, which country, but when we work in the government, Malaysian government, for example lah, previously I experienced with the Johor government. When we do like a store a file, usually when they don't want to store the file, they will transfer the file into the specific specific location. I mean maybe specific cupboard or whatever is specific location. And then if the within the 5 years they did not touch the files in SOP, they will take it out the file and they can burn the file in the fire. This is how they are do in the real life. I mean, I'm not talking on the in the database. I'm talking in the when they do how to store the file in the real life. Actually, we observe this thing from the real life, from how they manage the the data in life. Because the problem with the user, they have behavior like a careless. Sometimes maybe today they feel they don't like the data, they want to delete it, and then after that in next week, the data become like a useful, they want to retrieve the data. So if you delete it forever, so we cannot retrieve it. But here we still need to delete because there is some part we want to delete it. Because for example, if you want to transfer the data that you want to run the table and you want to put delete it, maybe we can put like a timestamp. For example, in 1 year, okay, this data will be deleted forever. So this is what I'm saying. So as a summary, basically inserting lets you add a tuple to a single relation. And update, of course, by using the words update, we know how to change the data in the tables. It also always need where clauses. Don't forget to add one. So delete is like a remove tuple from single relation, means forever. Delete forever. And it also needs achieving strategy. Most productive database don't discard all tuple entirely, because maybe today we don't like it, but maybe tomorrow we like it. Never work in auto commit mode because making changes to a database. So that means why we never work in auto commit, the reason is when we do our auto commit, so that's mean whatever we type, the SQL, you make the chambers in the whole entire database. For example, in previous year, I'll do this kind of the database, and this kind of the database already running and start running in the coming, and they start running by the user. Suddenly, after 1 year, after or 1 year or 2 year, I need to make a changes in the database. If I use the AutoCAD, what will happen? Yeah, okay, it's okay. But if I slightly, do like a mistake in my command and do auto commit, what will happen in the database? It will affect all. So the thing is, we don't want this kind of thing. So in practice, usually we don't use auto commit. That's why in practice we use only commit only. So be in mind of this thing. Okay, the last one, check whether the outcome is expected before issuing a commit. Okay, DHD. So the portfolio task sheet is good start place. So this is the task for the DHD. Actually, this thing we can see at the Canvas module. I already put the D and HD task also. If you want to go to HD, you can solve this problem. And then be in mind. So we in week 6 we already did this as a week 6 lab. We did this thing as a group right. Actually, this thing is something with the week 6 lab assessment. But the thing is, we need to focus in person only. I mean, in the personal only. I think maybe you can use from your experience when you're doing the week 6 labs assessment. But however, I hope the outcome of the this task, I mean the D and HD task, I hope it's not same with the previous one. Maybe you can make changes or whatever. Uh, don't worry about this thing. This thing I already put in the Compass module. And then I hope all of you guys can go to the D task, because already upload the previous work student. I mean from the previous semester, they already done D and HD task. I think you can refer from that sample, which is already upload to the Canvas module also. So this is open question. So basically, I want to ask about the explain why the customer order table is not the third normal form. You need to explain why. So this thing you need to answer. Be in mind, we don't have any physical class anymore, and then nowadays the management will measure the student participation in Canvas as replacement as students participation in Canvas previously. So how to do like a student participation in the Canvas? I hope so. This is you can answer this question. Okay, so please answer this thing in the week 7 uh, lecture and lab discussion. Okay, thank you. I think that's all for today. So see you next week. Okay, thank you.